Okay, back with problem 77 from the AP practice test. Now this is an example of a problem that we actually don't need to use a calculator for, even though we're allowed to. It's understanding that integrals are indeed area under curves. So the best thing to do in this type of problem is actually to sort of sketch out a little section. So if I look at this function right here, this integral right here, I'm going to represent 0 to 3 equaling 6 as just a rectangle. And it's not that it necessarily is a rectangle, but from 0 to 3 being 6. And then from 3 to 5 being another rectangle, that's 4. And then I need to look at this function right here, this integral function right here, and it's asking me what it is. Well, a couple things. The limits are different, so it's from 0 to 5. So it's the total inclusion of this part right here. So these two together are 10, but I'm multiplying it right here by 2. So this part right here is going to be 20. Okay? Because I have this shaded part, which is 6, added to this shaded part, which is 4. That would be 10 times this 2 right here would be 20. Then I've got this 3 here, and I could think of it as a fundamental theorem where I'm taking an antiderivative, but I could also just sort of think of it as a rectangle where this entire function has been moved up almost, and that now there's just this rectangle if you think about it. I'll try to sketch it out here. Let me change the color. If I have a function that's down in this region, and then it has some width, well now it's going to be moved up by 3. So I'm basically adding this region right here. Okay, so this is adding to my 6 here and my 4 here. Well, what is the area of this shape here? Well, it's simply 3 by 5, or 15. Okay, and again, these are multiplied. This was multiplied by 2, so that was 20, which we represent here. Add it to the 15, and we get 35. Answer choice D. Kind of a cool problem conceptually. I wish that I had probably talked more about these problems in class. The concept of area being, integral being area under the curve is something that I probably didn't stress enough this year in class. We did our area problems, but just all integrals being able to be represented as area under the curve is important, and something I probably did a poor job of that this year. But the year's not over, so this hopefully puts that in your brain, and I really, really enjoy this problem. Watch this one a few times until you can really understand this. You'll see this a few times on the AP exam to get those 1 or 2 points, but understanding this conceptually is worth a lot. Alright, I'll see you back for the next one.